start recording. Share my screen. We'll go ahead and just share my lesson 1 notebook. And can you all see it okay?
Yes.
Awesome. All right, so I'm just gonna go ahead and blast through this right away and let it train. That way we can sort of see what the results are. But I'll explain the intermediate steps as we go. So this is just the pets problem. So, this is classifying, I think it's 37 different species of cats and dogs at once. And we're going to sort of rework it in a way that's multi-label. And the reason behind that is when we, built the lesson 1 classifier, which I'll actually just pull that up on my repo. Back in, the old version of the course, before it was just binary classification like we saw the other night. Let's see if I can scroll down to it. We had something like 37 species of cats and dogs, and we tried to identify which one of them was in a particular photo, right? Well, what if, per se, I wanted to tell my model, I don't know what's there. I don't think it's one of these cats or dogs that are present. Or in some cases, possibly have my model tell me multiple classes are there. We're going to experiment with that today. The theory should hold that it might be able to pick up on multiple classes, but we'll check for sure as we go along. But sort of the question becomes, well, how do I train a model that sort of has this behavior of, well, I don't know what the heck it is? We can do that through multi-label classification. I believe at one point Jeremy brought this up in one of the course lectures. It might have been the version 2. But the general idea is, so when we're building our regular image classification model, everything gets sent in through what's called a Sigmoid, or an argmax function. And so essentially what that does, let's see how long this has to train. It has a little bit, but I'll show an example in a moment. But let's say we have like probability 0.2, 0.4, and what would that be? 0.42, and we'll go 3.8. So I trained a model, told it to identify 3 different classes, and I threw it a class, and it gave me this sort of probability scope as a raw output. So that is when I did, learn.predict, XYZ file, it gave me these raw outputs along with, maybe class of Husky. What that means is we applied what's called an argmax function, which will look at these 3 probabilities and point to whatever one is the highest. Now, it'll do this on a scaling factor, though. So this is what it looks like after we've done this argmax function, where, all of these sum up to 1. What this probability scope could look like after we
softmax, right, Zach?
Yes, argmax.
Softmax.
Softmax. Yes,
right.
Thank you. Yes, softmax is rounding everything. Argmax is taking then the highest. You can correct me if I'm wrong there, but I believe that's the idea.
Yep.
Awesome. What's really happening whenever we output our model, that's happening sort of behind the scenes when we do predict, is in actuality, the results could be something like this. Where, it doesn't sum up to 3, but because of the softmax function that we're applying, this gets scaled to where everything rounds to 100%. And so we go from this, less than 1%, 2%, and 3% to 20, 38, and 42. Now, it might not be perfect math. This is just an example. What multi-label allows us to do is it follows instead a sigmoid function. And what the sigmoid function will do is look at each of these probabilities and we'll give it some sort of threshold. And it'll say, okay, am I, within my threshold for any of these three values? Remember, this is not after we did our softmax. This is just the raw probabilities. And if I am, then I'll go ahead and say that a particular label is present. And so for this case right here, if I, for instance, set my threshold to be anything above 2%, then class B and class C, we would say showed up, or they are present in the image. Now, with this general idea, you could then have the concept of, okay, if I have 0.2 here as well, because everything is independent of each other, all the classes show up.
It's a quick question there, sorry.
Yeah.
So the sigmoid is applied on the raw probabilities. The threshold is applied to the result of the sigmoid, right?
Yes.
Right, okay.
I have another question. How do you select this threshold?
So the easy way to go about doing that, it's not going to be on the loss function. It's going to be on the metrics. So now that it's fully loaded and everything, let's walk through sort of the data block to set up single label for multi-label, and I will go through exactly that point. That work for everyone?
Yes.
Awesome. So a really quick and fast way to do this in the version 2 library. In version 1, while Jeremy talked about the idea, it was a little difficult to set up. I didn't actually manage to get it set up. But in version 2, with how everything is transform based, I can build a simple transform or a function that takes in some input, in this case a label, and returns it as a list, because that's what multi-label is expecting. You'll notice that we're using multi-category block. This is the same thing as saying multi-label classification. And with this transform, I just simply pass it into my getY. So we have the regex labeler that we're used to, followed by this transform that just returns the label as a list. And this is because we know for a fact all of my labels are individual classes. Yes, thank you for pointing to the multi-cat notebook as well. And so after we build this sort of data block, we can go ahead, call the data loaders, and you'll notice that it looks exactly how it was set up for the original pets dataset, where it's just one label is present all the time. So we can go ahead and now train our model, which we're going to use a new loss function, and we're going to use some new metrics. So the loss function for multi-label is binary cross entropy loss, and FastAI's version is this with logits loss flat. Now, I haven't looked too much into this, so Aman might have better answers for me, unless I'm throwing you under the bus here, which is perfectly okay, as to how that sort of operates as a whole. But my general understanding is similar to the concept that we described earlier, where we sort of look at everything that showed up and see if it follows a particular threshold value. And
I think
yes.
BC logits is what is there in PyTorch. FastAI's version is converting it to flat. So the logits is basically using it with the one-hot encoding.
Thank you.
So that's how you kind of compare it.
Okay.
Yep.
That makes perfect sense. And then for our metrics, we can't just simply use accuracy anymore, because accuracy is for single label classification. Instead, we're going to use accuracy multi, which acts on another threshold value. So in our case here, I'm going to pass in a threshold of 0.1, which basically, I believe, it's a little backwards, says that anything that's above a 0.9 I want to say will show up as a positive. Am I right in understanding that, Aman, or is it backwards? Because it operates kind of the same way as the binary cross entropy loss logits. But we'll go ahead and look at the documentation real quick. So it's if, and yes, it's if any of the inputs are greater than the threshold. We can see this right here. So for all of my inputs that are greater than the particular threshold, we check to see how many of them were correct. So what that means is if any class shows up greater than a 10% guesstimate, then we'll go ahead and call it present. So for example, we could say we only want like 90% or higher as our threshold, then we could put a 0.9 there. For this example, because it's quick and easy, I just put 10%, so if the value just shows up, more or less is what that'll wind up turning into. And we go ahead and just train how we normally would, and we use, you know, a standard accuracy function, so we can read it kind of the same way, but know that this accuracy multi is based on did all of the labels show up. Now, we're training, now even though we could have unlimited possibilities, we're training our model under the assumption that only one value should really ever be showing up in all the instances I'm training with. And so what we'll find is whenever we look at the results, only one label is actually showing. Also, one nice thing with multi-label classification is you'll notice that everything is labeled in green and red. Green means good, red means you got it wrong. Is there any questions related to that?
Is the color coding set up only for multi-category or even for the normal?
No, it's I believe it's multi-category only.
Oh, okay.
But
yeah, I didn't pull up show results, so I can't remember. But I thought someone shared a notebook, which I may be wrong.
That's okay. It's certainly something we could look at a little bit later, and I can just do a quick run. So if we look here, you know, everything that shows in green shows that our model does pretty good at saying, you know, this particular value shows up greater than 10%. And what the models learn to do is to give only one result. Because that's what we're saying fit to. That's what we're saying your y is going to be. The model has learned through the loss function how it should operate. So kind of an important concept there is loss functions are important because it can define the behavior of your model. So now, for instance, the example I show down here is I have a picture of a donkey. We never trained on a donkey, right? We only trained on dogs and cats. Now, if it was just regular classification, we would be using, you know, that softmax and argmax function, and it would give us a value. It would say this could be like, you know, husky, for instance, even though the probability might be 0.0001. But because that was the highest, it's what we went with. Now instead, since we're looking at all the raw values, if nothing passes our threshold, we don't give it a label. And so here we have a 0. Let me try and upload and find the picture of this donkey. Actually, here, we'll just go with my face, just because it's right there and available. Now, the idea is that if I upload this and do predict, see how I get nothing again. Let's look at what really is going on here. So we can see all of the outputs. We have Booleans of whether or not the value was above a threshold of the threshold that we set. And we can look at the raw tensor values of what each of them were. And so remember our threshold was 0.1. None of these values are above 0.1, and so nothing shows up. And there's a few other techniques for doing sort of a label is never present. Bayesian networks, I believe, is one way of going about doing it. But from a FastAI perspective, and from the tools that you know and the tools that we can use natively in the library, this is the easiest way to go about this problem. Now, if, for instance, we wanted to do something along the lines of, say, count how many instances of a label was present, because, for example, I could do an image like this, where it is, it's not a PNG, JPEG. All of these Rottweiler puppies. Well, if I go ahead and predict on them, I don't believe we had Rottweiler in one of the categories. But what would essentially wind up happening here is only the Rottweiler category would get lit up. And so we would only have one category here that was Rottweiler. It's not, 5 Rottweilers. A way to sort of bypass this would be to sort of mix in image regression. And the general concept for this case, and how you would set that problem up, this is mostly theory, I haven't tested this, but this is how I would go about that particular problem, is let's say I was classifying just strictly dogs and cats, and how many dogs and cats show up. I would have 2 Ys, essentially. I would have Y1, which is cat, and the second, which is how many instances of each animal are in my image. So, for instance, here, let's say we have 3 cats but no dogs, and cat is the first category. I would have 3 here, followed by 0. And what I could then do is use something like image regression, add it on top of our model. This would be as simple as putting a second head in. I'll link a notebook that sort of describes this here in a moment. It's the hybridizing models. Actually, not hybridizing models. Multimodal head. There we go. That sort of describes what this process would look like on a different problem, but the general idea is your model would share a body. All right, so that would be the encoder. So in our case, it shares a ResNet 34. And then, all of our models have this one individual head. Well, what we instead do is give it multiple and adjust for this in, say, the forward function. So I have like class my model. We'll just call it a module. If this goes a little advanced for you guys, don't worry about that. The notebooks in my repos kind of go over this, that exact notebook I mentioned. So if I was generating a model, in this case, for my multimodal model, I would want to pass in a body, or our encoder, the first head, and the second head. And what we can do is store those away. So we'll have self.body, self.regression head, and self.classification head as body head 1, head 2. Are we all kind of following me at this point still? Or anything I need to explain a little further? All right. And then for every model, we have a forward function that expects some x. And so to get sort of these individual head results, which we can kind of think of as two separate models in one now, because instead of simply having a classification model, we're trying to do classification and regression at once. We'll first pass our input into the body, and then we'll keep track of two different y values. So we'll pass that x into the regression head. So we'll do regression. And then we'll also pass it into the classification head. And now our output is a two-dimensional tensor with our regression and our classification. And what this will wind up outputting is something similar to this tensor here, if we had, say, 37 classes, followed by another tensor of 0 times 37. Another tensor that is a bunch of essentially decimal numbers, so individual points here, of how many points were there. So this could be like, 0, 1, 2, 4. And as long as you set up your problem accordingly to where the order of these values match the order of your classes, then you can line up, okay, this was class 1. It said that class 1 was there how many times I look at this first value. To set it up sort of in a data block format for you to get this, you'd probably wind up defining two get y's. So you'd have like maybe get y that has an O, and then you'd have the first one that does the regex labeler. And you pass in O. I'm just recreating what we did above here with the get y. And then we'll transform that label. And then we'll also have some method to, say, call a particular data frame to grab our row of numbers. So that could be like did points equals, say, data frame nums where the image name matches O. And the reason why this works, for those of you that aren't familiar with necessarily how this is all working, I'm going to go ahead and show a lambda function that'll print what gets passed in to get y. And if we look at what winds up getting printed, we have this very, very long file name here. That is what O is whenever we pass anything into get y. So that's what it will get instead. And so we can work with that to, say, go into our data frames. Is there any sort of questions on that? That's a sort of an advanced topic per se, because we haven't really covered that a whole lot since it is just lesson 1. So if there's general questions about get y or any of the data block aspects, I can answer that too. All right. So that's the general concept of sort of how to tell a model, I don't really understand quite what I'm looking at. It's not really something that I was trained on. And sort of a way to keep track of, if I do have this particular dog breed present in this photo, how can I count how many of them there are? If there's any more questions about this, there's a thread that this sort of idea started from. Let me see if I can find it real quick. This was started by Kodzax. Sorry if I mispronounced your name. That this sort of idea and general discussion began, and I believe that we can just go ahead and use that as sort of a mini discussion specifically on the idea with the multi-label. Anything else, probably post in the advanced category. I believe would probably be the best way to go about doing that.
And just to add to that, probably like chapter 6 also covers that really well in the book.
Yes, thank you. Let's go ahead and open that real quick.
And that, yeah, you can see how you kind of go about selecting your threshold too. I think that was Kodzack's question.
Sure, yeah. So when selecting your threshold, it's kind of data dependent and sort of dependent on how your model winds up behaving and what's, good enough, what's not good enough. Because remember, it's anything that shows up over a particular percentage value. And so if you want a model where it's, not really supposed to explore a whole lot, only get straight to the point, you could set that threshold to like 90%. And so you only get back values if your model is extremely, extremely confident it is this class. But, if, say, in this instance where we had 10%, I didn't really care per se. I wanted the loss function to go ahead and let it learn on its own. And so we just had this 10% value. And that's why this first epoch had 8%. And then after going through the data once, it automatically went up to 98%. So does that sort of explain that concept to how you're hoping?
I was just saying that in the book, Jeremy kind of goes about how you can use your validation set too to kind of pick that threshold out with a nice curve.
Oh, really?
Yeah. If you just scroll right about the regression part, I think.
Binary cross entropy. Let me know
right
if
there.
Okay.
Right there. Right above regression.
All right. Oh, right around. Right above, you said?
Above, yeah. That graph.
Ah.
Yeah.
Ooh, very, very interesting.
Yeah, it's a pretty cool one. And he talks about like how this is not overfitting, though you're using your validation set, and kind of how you would perceive that as like cheating.
Well,
so it's a nice write-up there.
Absolutely go explore that, because I've never read that before. And I don't believe I've heard that mentioned in Jeremy's lectures before.
I've also not heard that before, yeah.
I'm going to study this chapter very, very carefully. But awesome. Great find. Thank you for that.
Sure.
But otherwise, if there's not any more questions, I'll go ahead and stop the recording.
I have 2 questions about data blocks. Do you want that off the recording? It's not related to this per se.
Sure. Let me go ahead and stop this.